Morning guys. So in this video I'm just going to show you what this task is all about that I've set you, and the main purpose of this is to give you a chance to practice the graphing with the software that we're using, and to just show you how to do one of the examples, and then you will need to do the other two, and you'll follow exactly the same process for those, so you can re-watch the video and pause it if you need reminders about how to do anything. So this spreadsheet that I've shared with you has 4 tabs along the bottom. The first one is just this little bit of instructions, and each of the tabs has a set of data. So if you click on these tabs, you can see here's a set of data from an experiment, here's another set of data, and here's another set of data. So I'm going to go over how to do the first one, and then you will need to do the other two in the same way. So this is the same process that we went through with the data that we collected in our last lesson. Okay, so in this experiment we have someone who has connected a power source to a resistor. The independent variable was the voltage that was set on the power pack, and the dependent variable was the current measured in the ammeter. So basically what this student has done is just connected 2 wires to a resistor from a power pack and then changed the voltage and measured the current. You might have done something similar in year 10. Okay, so our first step in these is to work out what the average is. And remember that the way that we do that is we write equals, then we write the word average, then we open a bracket, then we select the 3 cells for the 3 bits of data that we want to average, we close the bracket, and then hit enter. And that works out the average for us. And then to work out the average for each row, we're going to grab this little blue square at the bottom corner of the cell and just drag it down. And that now gives us the average for each of these sets of data. If the decimal places look funny here, which they don't in my case, but they might in some of yours, you can increase or decrease decimal places using these buttons here. Okay. Now, the next step is to create a graph of the voltage, which was our independent variable in this experiment. That's the one we changed. That's going to go on our horizontal axis, and the average current is going to go on our vertical axis. So what I'm going to do that is just temporarily, or in fact I'll just hide these 3 rows, because I'm not going to be graphing those. Those are just what I was using to work out the average. So I'll click on, well, I'll just do that again and say what I'm doing. So click on B, and then hold down Shift, and click on D, and then let go of Shift, and then right click, and then hide columns B to D. That makes those columns vanish. And then I'm going to just select all of the numbers in this table like this, and I'm going to choose Insert Chart. And I get a graph that's already reasonably well formatted, but there are a few things that I need to do to change it. So I'm going to now work on just fixing up this graph. So the first thing that I want to do is click on Customize, and I've got the correct chart style. It's a scatter graph. I then want to go to Chart Axis and Titles, and I want to change the chart title because average isn't clear enough. So I'm going to say average current measured in amps. Okay, so now that looks correct. I might just center that because I think it looks nicer. And then I need to also fix that my horizontal axis is correctly labeled, but my vertical axis is just labeled as average. So I'm going to fix the vertical axis here as well. And I'm going to change that to average current in amps. Remember to always include the unit in everything that you're doing. Okay, so now I just check that I've got my labels correct here. They both look good, and the title looks good. And for the title, by the way, we always write what's on the vertical axis first, and then we can write versus what's on the horizontal axis. Okay, so that's the title sorted. The next thing we want to do is click on the series button, because there are a few things we need to do in here. And we scroll down to where it says point shape. And we're going to change it from blobs to X marks, because they're neater. And then, still in the series set of options, we're going to choose trend line. and it's linear. Blue is okay. And for label, we want to use equation. Okay, and that gives us our equation here. So that's now fine. And then I'm going to just minimize the series options. And I'm going to skip the legend one because I don't need a legend for this. That's just if you want to add extra labels. And I'm going to click on horizontal axis. Now the main problem with the horizontal axis here is that it starts at 2. We want it to start at 0. So we want to change our minimum value to 0. And now we can see that that goes nicely through the 0 point. Okay, and that's all we need to do with the horizontal axis. So now this graph is looking pretty good. We don't need to make any changes to the vertical axis. If the vertical axis didn't start at 0 here, then you might want to change the vertical axis minimum to 0 as well. Okay, so that graph is now looking pretty good. I'm just going to resize it a little bit here like this and just plonk it down here. Oops. Okay, so that doesn't quite fit because I removed those columns. I'm just going to take these things and chop and paste them in here so that I can fit this in here. Okay, so now I have my graph. From the graph I can now determine the gradient. The gradient is this number that appears before x, and remember the gradient is how steep the line is. So this number here says that for every 1 volt I go up, the current is going to increase by 0.252 amps. So the gradient is 0.252, and the units for the gradient, if we want to include those, is whatever this unit is divided by whatever this unit is. So in this case it's going to be amps per volt. So amps over volts. That's my gradient. Now the equation, this has already given us the equation, but it's given us it with x and without a y value. So the way that we change this equation to an equation that we can use, in fact can we just copy this? Oops. No. No, it's not letting me copy it. I'll have to just write it out. So we can write then current, which is our vertical axis variable, is going to be equal to 0.252 times, and instead of x we're going to write what we had on the horizontal axis, so that's voltage. And then this is a tiny number. This 3.55 times 10 to the minus 6 is that with, so if we wrote this number out normally, we would have 0.1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 355. That's what that number would look like. But that number is so small that it's close enough to 0 that we don't need to worry about including it. So we don't, so it would be plus that tiny number, but it's basically 0, so we don't need to include it. The relationship here is, we can say, I'm just going to make this a bit bigger. The relationship between current and voltage, in fact, actually I'm going to say it slightly differently. I'm going to say the current, or the graph, shows that our current is proportional to voltage. So we can say here, the straight line graph shows that our current is proportional to voltage. Just like that. And then we can write our conclusion. And our conclusion, actually we don't really need a conclusion. This is the conclusion. And I'm just going to pop that so it sits at the top rather. So that's basically all we need to do. So just so that you really learn that process well, I've set you the task now of doing that for these two sets of data as well. You'll notice that the variables are different. So in this one we have a student dropping a toy connected to a parachute and timing how long it takes to hit the ground from different heights. And in this one we have a student placing large weights in the middle of a trampoline and then measuring how far it sags down. And so he's got these values in centimeters, and these are the values in kilograms of the weights that he's placed on the trampoline. And you need to go through the same process to get a graph, find the gradient, find the equation, and find the relationship. Don't worry so much about the conclusion. Okay, so good luck with that. I've also created a Quizlet for you guys so you can review some of the terminology that's going to be important for this task.